let's talk about where we were before. We had like a circle that was moving around, right? And so if you're, we're gonna make, let's start with just like a bouncing ball around the screen, a more complicated application here. And we need to create variables, but this time, instead of just creating one variable, we're gonna create 4 variables. So in x equals maybe 400, y equals 100, vx equals 3, vy equals 2. Okay? So I'm going to create 4 variables and then draw an ellipse at the location of x, y. Okay? So this is the program so far. I'm going to run that program. So now we have an ellipse and we want to move it. Like we previously saw, to move the ellipse, we're going to say like x equals x plus something. Specifically, we want to change x here by the vx variable. So we have to do x equals x plus vx. But some of you more advanced programmers might know that you could actually do also x plus equals vx. Okay? And so we can move both x and y to get the ball to move both horizontally and vertically, because we've used the x and y variables to represent both the left, right, and the top-down position. I'll make the circle also red, so it's a little bit more clear. So this is how we would make a vertically moving ball. If you're an older student, you're familiar with variables. Maybe you've done some animation. And also, you should start learning about how computers make decisions, because computers, they can hold information and they also can make calculations, but they also can perform logical operations, which are also a form of math. Specifically, we can say, if the ball is on the right side of the screen, change the x velocity. We say, if the ball is greater than 800, change the velocity to -3. This thing is called an if statement. And if statements allow the computer to make decisions. And the great thing about them is that every single program whereby something is happening that can be different each time, not just like an animation that is the same, that requires if statements. Your computer can perform billions of if statements every second. Okay? And so as you can see, by adding this if statement, the x changes to -3 when the ball hits the right side of the screen. And so you get a bouncing ball. And of course, we might want it to bounce on all 4 sides, so you can use the same kind of logic, making sure to balance the curly brackets, because older students will be forced to do that, to make it bounce, for example, off the bottom of the screen. So you learn about if statements, learn about things such as syntax, curly bracket completion, statements, what are called scopes. And additionally, if you want to bounce it off all 4 sides, students online, you can make it bounce not only when x is greater than 800, but also when x is less than 0. This thing is called an OR operator. And it evaluates to true if either the left side or the right side is true. And so OR operators check both sides and run the if statement if either is true. And that will allow us to create logic that executes on both the left and right side. And so I will copy the code as it is to the pad for those of you who are trying to catch up. And so it's pretty cool. We can make the computer make decisions. But additionally, we can make the computer take user input. And so, for example, right now, we're just drawing an ellipse that doesn't interact with the user. But we can use the, for example, mouse and keyboard information as variables within the application. So for example, we can draw a rectangle. But instead of putting just 4 constant numbers, I can use the variable mouse x. And then if I use the variable mouse x, that will allow the rectangle to track my mouse location. So I'm going to run this. And now this new rectangle is also going to be red, tracks my mouse location. I can even use this command called rect mode center to make the rectangle draw it with the X location centered around my mouse. So that allows us to take input through the mouse. Furthermore, we can take input through the keyboard. So let's say I want this game to maybe start with some instructions. I can create a variable that in the beginning makes the program check if it's 0. And if it's 0, make some intro screen where, for example, I draw the text, welcome. Okay. So now, this program, instead of playing the game, because state equals 0, it just draws welcome. And I can even make it say like welcome, press S to start. And the cool thing is that we can use this variable key pressed. We can say if key press is true, then change the state to 1. And so you can make applications that not only take mouse input, but now if I press the S key, the game begins. So we can take both mouse and keyboard actions. Okay, and that pretty much concludes like the lecture that we had prepared for the processing class. Obviously, we learn more than this over the course of a semester. But I want to talk lastly just a little bit about the class format, rather than kind of go deeply into the curriculum, and rather than doing loops and arrays and classes and objects and references and algorithms and data structures and whatever, that you can do online. I want to talk about a little bit about how you could use our services to do, for example, free learning, and also what kind of our courses are structured like. Okay. So if you've been following along online and you want to kind of keep learning on your own, one of the coolest things we have are all these free audio lectures. You can go to the presets tab on the left side and find tons and tons of pre-recorded lectures. And these allow you to learn about, for example, like I just said, loops or strings or arrays or classes at home at your own leisure, and practice with tests that automatically run and evaluate your code in the web browser. Okay. Additionally, like I showed the other students, you can access projects on the website, copy, modify, experiment with their code, and rerun them, re-export them. And as well, you can access things such as interactive textbooks and material to help you kind of structure your own learning. So the material we've been covering today is in 2 of our classes, or 2 types of classes, more or less. When we started this hour, we were doing block-based programming. And specifically, we were using Java blocks. This is called our Fundamentals 2 curriculum, and it's suitable for students who are before high school. And Fundamentals 2 usually assumes you had some programming experience in Scratch. At least you've made some substantial applications on your own. And so if you haven't done Scratch, some students will start with the Fun 1 curriculum in Scratch, especially if you haven't done Scratch features such as cloning or broadcast, some of these are kind of more advanced concepts. But the big difference from Scratch Fun 1 and from Fun 2 is that Fun 2 students using Java blocks can make syntax errors, and so it's definitely a lot more advanced. It's a real programming language whereby you're able to use the same syntax that adults would use when they're doing software engineering or research or whatever. Fundamentals 3 and CSOA, that's the processing stuff we were doing in the second half, where you type your code and you don't have to drag every single block. Okay. And that's entering either upper middle school level or high school level. And so there's a commensurate increase in not only syntax, but also like responsibility. Older students are expected to do things such as go to office hours if they need help, do problem sets where there's substantial thinking that they have to do for every single problem, not just like worksheets that maybe middle school students are familiar with, but whereby every single problem requires you to read like a few paragraphs, think about how to solve it, and write an open response answer. Okay? And as they advance up and towards the college level curriculum, they're exposed to things that you would expect to learn in a rigorous computer science course. And so if you're a software engineer, you're familiar with concepts such as recursion, computational complexity, algorithmic problem solving, etc. And these are things that the curriculum really tries to enforce. And so you'll be able to not just like make one app, but think about how to make any app, any program. How does technology work in our modern era? And we really want to empower students to do any of these things. And then finally, we didn't get to demo any of our college level curricula today. And in reality, none of our students are college age. They're at most high school age. So these are college level classes for high school students and a few very ambitious middle school students. But this allows them to, for example, prepare for and beyond the AP Computer Science exam, do machine learning research at a undergraduate level, participate in national competitions such as the USA Computing Olympiad, and build generative art and other kinds of art pieces that they might want to showcase as part of art portfolio or their personal portfolio. Okay. So these projects and games that the students are doing right now in class are just the first stepping stone. But I hope you've enjoyed it, and now we'll open ourselves up for just a few minutes of questions to the online audience. And you can just type in the question section, and I'd be happy to answer anything you have to ask.